Well, hello there. I hope you're doing well. This video is going to be discussing what happens when you combine functions together, and specifically the challenge or question of finding the domain of that combination of functions. Now, this video will only really discuss combining functions by these basic operations, not the function composition process. That's going to be handled in another video, all right? So this is just about finding the domain of a combination of functions using your basic operations to combine those functions. And what I mean by that, all right, by basic operations, hopefully that's somewhat clear anyway. But here's the rule that we have to follow. Whenever you're combining two or more functions with basic operations, and by that I mean addition or subtraction or multiplication or even division, the result of doing that combination is another function. And so the question is then, well, is the domain of that new function the same as what we started with, or is it somehow different, or how do we figure out the domain? And the basic rule is this. The domain of that resulting function, which is a combination of some other functions, is the intersection, or sometimes we say the overlap, of each of the contributing functions' domains. Okay? So we have to look at each domain of the domain of each of the contributing functions that were combined together, and we find the overlap or the intersection, we say, of those domains. So there's a little asterisk there after the domain, and that is because this is a little bit different when we are dividing functions. Okay? And that's because, as you are probably, if you just think about it, why would division be any different than multiplication or addition or subtraction? And that's because we can't divide by zero. So anything that would cause the denominator of our resulting function to be zero, we have to pull that out of the domain. So that's what we're going to talk about, is this little issue with the domain. And so I've set up just one example here, really. X squared minus 1 for one of the functions, and the other one, g of x, is the square root of x plus 1. So we'll just take a look at this. A basic operation, if I took those functions and then just added them together, f plus g, frankly, it's not really very interesting. There's not that much to do to it. It's just x squared minus 1 plus the square root of x plus 1. There's no like terms to combine or simplify. That's pretty much all there is to it. You're just adding the terms together. But it is a new function. And so the question is, what is the domain of that new function? All right? So we have to look at the domain of each of the contributing functions. And if you think about it, the domain of f, which is a parabola or quadratic function, the domain of that is all real numbers. And g is a square root function, so we have to look at that expression there and make sure that we are only taking the square root of a positive value. And so that would mean that x has to be -1 or greater. So anything in that domain there, bracket -1 to infinity, will work for g. The overlap of those two domains, well, that's not too hard to find, since the domain of f is all real numbers. That's everything. So that totally includes the domain of g, obviously. At least I hope it's obvious. And so the overlap, the place where those two things are common, is just the domain of g. All right? So the domain of that f plus g, well, we could write it with that intersect symbol right there, but usually those expressions can be simplified, like this one certainly can be, down to just bracket -1 to infinity. That's the domain of f plus g. And any other combination of f and g, f minus g, g minus f, f times g, all of those would have the same exact domain. Once you worked out what the function looks like, its domain would be bracket -1 to infinity. Okay? However, we may have a little problem if we try to go f divided by g or g divided by f. So let's take a look at that and make sure that we can figure out what the domain is there. First, let's look at f divided by g. And so there you see the function x squared minus 1 divided by the square root of x plus 1. And we just cannot let the denominator of the fraction equal 0. And our only issue really here with our original bracket -1 to infinity domain is the fact that we cannot now let x equal -1. That's really our only issue here. And so we just make sure that when we say this new domain, that it's using a parentheses instead of a bracket. So -1 is no longer part of the domain. It was before for the other combinations, but when I divide f divided by g, I cannot let x equal -1. So I pull that out of the domain. Now, if we take the reciprocal there, g divided by f, that's what it looks like. And now we have to think about x squared minus 1 being the denominator of a fraction. If you think about that, well, geez, there's actually two numbers that will make that denominator equal 0, -1, or +1. So both of those have to be removed from the domain. And so what it looks like when you take with the parentheses there of the domain of f divided by g, looking at that, and now if you imagine pulling out the value of +1 out of that domain, what it looks like is this. It's using the interval notation and the union symbol there. And just to be clear about how we get to that, if that's not clear enough the way that is right there, if you think about graphing the original combination domain there of bracket -1 to infinity on a number line, it would look like that with a solid circle there on the end point and just an arrow going to the right. Now, when we did f divided by g, the only difference was we replaced the solid dot with an open circle, so to speak, or we replaced the bracket with parentheses. So not much of a difference, but an important difference. And then when we flipped it over and did g divided by f, we have to pull out +1 out of the domain. So there's +1, for example, and so we just have to, that's kind of what it would look like right there with the open circle on the graph. And so now we're just describing those two kind of separated intervals from -1 to 1 and from 1 to infinity, but just not including exactly 1. So that's how we could write the domain. We could also write it with this, what people call set builder notation. You would kind of read that as the set of x such that x is greater than -1 and x is not equal to +1. So that's the set builder notation for the same thing. I don't really care. My preference would be the interval notation personally, but they all work. Okay? So anyway, I hope that was enough of an example. Good luck, work hard, do some good math, and be well. Bye-bye.